So I want to go over the Chrome JavaScript debugger. And first, to bring it up, you can go to the View menu, Developer Tools, and that will bring up the JavaScript debugger, which is the Sources tab of the Developer Tools. And there's lots of good stuff to learn about this. The first thing I want to go over is a basic breakpoint. In this Sources tab here is the JavaScript loaded by the web page that you're looking at in this tab, and you can browse to the file of interest, and there's line numbers here next to the source code, and if I click a line number, that will set what's called a breakpoint, and all your active breakpoints are listed here as well. So when the code is executing, when a breakpoint is encountered, the JavaScript engine in the browser will stop right before executing that line and allow you to use the developer tools to do your debugging. So let's show you what that looks like. If I click this button here, you can see that the code is stopped and it says paused in debugger, and now I can look at this tab, which has scope variables, and I can see, okay, in this scope of this function there's a thing called event, and I can drill down and look at all the details of all the properties. So just looking at scope variables is a great tool in terms of understanding your code and the data that's flowing through your functions. And you can also look at the call stack, which in this case, since it's just a single event click, the call stack is very shallow, but sometimes in the middle of interesting code you'll have a really deep call stack, and it'll be interesting to see which code is causing this code to execute. In any case, then I can step over that line and continue to execute code line by line. And so that's your first basic tool for debugging, is setting a breakpoint, and we'll go into details of how to use each of these functions once the code is actually paused. So now let's step over some synchronous code. So I've got a function here that will get called when I click this button, and we can just learn about some of these guys. So this one that has a little dot with the arrow circling over it is step over, and it avoids going into a function call and just keeps going down the current file. And so for something like a regular for loop, you can just loop through this, and you'll see that we went on line 142, then 143, and when we hit step over, we'll go back up to 142 because that's what a for loop does. And we can see that our loop counter here is now 1, and as we go through the loop, we can see it going up. And we've got a tiny loop here, obviously, and lots of times you might have really long loops and it would get tedious to step over them, but in this case we're just going to walk through this. And then for contrast, on 145 we're going to do that same kind of loop but using a for each iterator function. And so if I want to get into line 146 without stepping over it, because there's a function defined here, I have to use this button here with the dot and the arrow going down, which means step into. And that'll let me get into this function, the next level of indent here, and see line 146. And then on 146, if I hit this again, the only thing here is a function called console.log, but that's native code, so you can't step into that. So you just step past it. And if you just keep hitting step into, you'll stay in this loop and see all the iterations as the word variable changes with each invocation. And then we're done with this function. Okay, next we have some asynchronous code. And if I set a breakpoint at the beginning of this asynchronous code, we get to see what I think is really interesting, or a key thing if you want to understand asynchronous code and use the debugger. I think this is a key concept to get. It's really not that complicated, but many people actually don't understand the order in which your code is executed when there's something asynchronous and exactly precisely what that means. So I have some console.logs here to hopefully clarify this. So here's a few lines of synchronous code. We're going to log some stuff, and if I click here, I'll see this is the little view of the console here, so I can see these statements happening. So I'm going to do an AJAX request, and all this stuff here is synchronous so far, and then in particular when I call send, that's going to be asynchronous, and the browser is going to go and actually send the request, but the code is going to continue executing even while that request happens. So we can see this console log keeps happening, the request hasn't returned yet, and this code continues to execute. And here I can assign the onload callback function, and I'll put a breakpoint inside that so I can see when that gets called. But when I hit that step over, I went right from 161 all the way down to 164, and 162 didn't execute yet because that's just defining a function, but that function won't actually be called until a different event loop. So there we are. 164 has executed, but 162 hasn't executed yet. That's basically the one thing you have to understand for async code. And then we can keep going here, and this function is basically going to end, and now 162 will fire because the XHR has come back, and we've completed our synchronous code. And so the next tick of the event loop, we're inside the onload function, and we have the server response. We can log it, and came back to request number 1. And so that's how you step through asynchronous code. And the key thing is you need to put a breakpoint within the function, within your callback function, to make sure you catch when the JavaScript engine executes that code. Okay, the last one I want to walk you through is when you have a bunch of asynchronous operations going on at the same time. So I'm going to set a breakpoint here when I'm going to launch a bunch of asynchronous stuff, and I'm also going to put one in 173, which is my callback for when a bunch of parallel AJAX requests start responding. And I've written a special server-side function called random delay that when I make a GET request, it's going to compute a random number of seconds between 0 and 10. It's going to wait, and then it's going to respond, and it's going to include the request number so I can tell which one it is. And this will just demonstrate that they're truly asynchronous, and the order that they return does not necessarily correspond to the order that the requests were sent. So when I start this off, I start off with request number 1, and I go through this little for loop, and I make a XML-HT request, and I send off request 1. And then I just, this is just all asynchronous, so my for loop continues to execute, and the browser takes care of that request in the background. And I can stop through these. I send a second one, I send a third one, I send a fourth one, and then my loop completes. And now I start to get my responses. So all that code is always going to send those requests in that order, 1, 2, 3, 4. But because I have a random delay in the response, these responses are going to come back differently. So when I look at this console.log, that's request number 1, which is just sort of by chance. And then there's number 4. Again, they're not, they're designed to not come in order to prove the point that I'm trying to make. So that one, the server code randomly decides it's going to wait 7 seconds and then come back with number 4. And then number 2 arrives, and the server decided it was only going to wait half a second. And then there's number 3. So that'll just demonstrate that when you're dealing with async operations, you can't guarantee any correlation between the order that async operations are started and the order